fast-paced world where everyday things are getting smaller and smaller. But it's still the really big things that power our world and keep us moving forward in a very big way. Coming up on Really Big Things, find out why a gigantic boat is laying huge concrete carpets on the banks of the Mississippi.
I got stuff flying over my head over here. I got things moving back and forth.
Then, what kind of really big machine gets a big kid like me all excited?
The rammer hammer and the crusher. Break it down, baby!
And later,
Okay.
the world's largest paper mill in Borlänge, Sweden.
We're making some paper here, people.
So much going on, a guy like me can really get wrapped up in his work.
What the heck is going on in Sweden? I'm here on the mighty Mississippi, North America's largest river, providing transport for more than 470 tons of cargo each year. Now, erosion from the old man's powerful current is a constant battle. It needs to be maintained with hundreds of miles of concrete. The only vessel equipped to create and place the giant slabs is the U.S. Army Corps of Engineers one-of-a-kind concrete mat boat.
Since 1948, this $25 million boat has been working to preserve the banks of the Mississippi by dropping giant blankets of concrete along the river's edge in a process known as revetment. All right, I'm here with Kel Sheridan, Chief Revetment Section, which basically means you're pretty much the mayor of this operation. Am I correct?
I guess you could say that, yes. How you doing, Matt? Glad to have you on board.
You know what? I'm glad to be here. It's a little bit hotter than I anticipated, but I didn't get that memo.
Well, it gets that way in August out here.
Yeah, I bet. Why do you guys work out here in the middle of the heat?
The river stage is at its lowest point, and that facilitates us putting the mat in the river. Basically, concrete carpet, approximately 3 inches thick, 140 feet wide. As they build that mat, we'll back the mat boat out from under it and just launch it off. It's kind of like a window shade going off a roller. And then it gets to the bottom of the river and flattens out. And then we'll build another launch, back out from under it until we get out, sometimes as far as 900 feet out into the river. We move this whole thing upriver approximately 130 feet every time we lay another mat with nothing but winches and cables.
On the actual bank, it looks like there was mats there before, and they're kind of crushed up. Why?
Most of the work we're doing right now is reinforcement and repair jobs. Real high water, currents are strong. It will flip some of the mats over. Another reason is these big towboats, when they're waiting on a southbound boat, they'll shove their tow into the bank while they're waiting on that downbound boat. That'll crush some of the revetment also.
All right, so tell me about the boat, because the boat is mammoth.
Well, the physical dimensions of it, it's 178 feet long, 74 and a half feet wide. It's got 4 overhead gantry cranes that actually place the concrete squares of mat up on the deck.
What do the mats actually do?
One is flood control, and if that water continually eats into the bend of the river, sooner or later it's going to get to that levee. The second is for navigation, to maintain the channel for the commercial towboats to run.
So we're in Missouri right now, and you're going to float this thing all the way down to New Orleans.
So we're going to cover about over 900 miles of the river this year. This entire operation, it's the largest hired labor operation in the entire Corps of Engineers.
So you're the big cheese of the biggest job.
You got it.
I had to find out why these bulldozers and men were pulling the cables off of the mat boat and moving them up this hill.
How you doing, my friend?
Hey, how you doing, man?
Good, I'm Matt. What's your name?
Woodrow Thomas. Welcome to the Mac City unit.
Thank you, sir.
Yeah.
So what's going on here?
All these dozers you see,
Yeah.
we got them anchored to hold that mat boat down.
The dozers are actually acting as the anchor.
Anchors.
All right, so what are the odds of you showing me how to tie one of these off to keep this bad boy anchored?
I'll show you how to tie one off if you promise to work with us maybe like another hour.
Pretty musty out here, but I think I can handle that, my friend. Let's go.
All right.
Woodrow and I are going to be using a 3/8-inch steel cable to anchor the concrete mat to the river's edge. Now, the cable is being fed to us from these giant spools located beneath the mat boat's deck. Where's my knot?
Right here.
My anchor.
This is called a square knot. Pull it.
Through, over,
Right.
and back through.
Go back over.
I'm so strong, I'm afraid I'm just going to snap it in half, you know? So this is tied to the concrete,
That's tied to the concrete.
and this is going to pull the concrete and anchor it down,
The concrete going to drop off of that.
right?
And then once it hits the ground, it will put tension on these wires.
I lock this thing down here. It's not going
It's
anywhere.
not going anywhere.
All right, Woodrow. What's a nickname?
Nut.
Nut?
Remember that.
Nut.
Nut.
Why nut?
N-U-T.
Why nut?
Long story.
That's another show.
Take care of it.
Thanks, brother. There's a fleet of 50 barges that keep the crew in constant supply of concrete. Each supply barge holds 585 squares of mat, which weighs a whopping 950 tons.
All right, I'm here with Joel Brown, mechanical engineer. I got stuff flying on my head over here. I got things moving back and forth. Tell me the whole process.
It looks like a little bit of organized chaos. You bring in a supply barge with your mat on it. These 4 gantry cranes will come in and picks up 2 at a time and brings them over those rollers on the deck. We got over 5,000 rollers on that deck. They lay them up in lines of 35 and tie them together, launch it all off in one go, and then do the same thing.
Why is this machine so big? Obviously, bigger, better. The more we can do, the better.
The bigger it is, the more efficient it ends up being. The more squares you can put in the river each time you launch off, the better off you are.
And then so, like, how does it work? Are we just moving downstream and we just pick it up as we go?
Yeah, we start out downstream and they overlap each other as you go up, kind of like shingles.
Oh, we're moving upstream.
That's right.
Why?
The water has a tendency, if it gets on the edge of that mat, it'll lift it up and flip it. But if you overlay them like that, that means your lap is downstream and the water won't get under it. It just gets under the very first one.
Oh, that makes sense, like a roof.
Exactly.
I noticed there's wires in between there. Why are those there?
That's right. When they cast them, they put a stainless steel mesh through that square and then cast the concrete over that. That stainless steel wire ties it all together and it's corrosion resistant. So 40 years from now, that square will still be in one piece.
Well, what can I do, man? There's so much going on. I want to get my hands dirty.
Well, we got a big machine and we could use a big man to help run it.
I'm with that. Let's go.
Operating the flying gantry crane looks like a fun job. I was on a mission to find out who is running that big machine.
How you doing?
Oh, that's fine, man. How you make?
Good. I'm Matt. What's your name?
Lee Davis.
Lee Davis.
Uh-huh.
And what is your job title here?
Cash operator.
Let me ask you this. How long have you been here for?
Oh, 38 years.
38 years.
Uh-huh.
When you operate, you know, I bet you guys would be really good at that carnival game. The claw comes down and picks up the stuff down.
Right.
I never went at that. Maybe we could go to one and you could hook me up. All right, so what do you say I hop in the seat and you let me drive?
That's operator, but you couldn't make it right now.
I couldn't make it right now?
Oh, no.
So how long do you think would it take for me to get in the screen? With that laugh, I had my answer. It was time to move on. All right, thanks, Lee.
All right, man. See you later, man.
Since I didn't have quite enough experience running the flying gantry crane, I started looking for another job. Tying the mat together with those bad-looking machines looked pretty sweet.
I'm sitting here with Mr. Charles Wren. Charles, what exactly is your job title here?
I'm the supervisor on this end of the mat boat.
So you're the boss.
Awesome, yeah.
All right, boss, I'm here to work for you. Put me to work.
When you bring the square over here, I'll show you how to tie it.
Okay, so we're tying the squares together to make one huge mat.
One huge mat.
All right, what's this machine called right here?
This is an air gun.
All right, so first of all, how do I work this?
All right, you put the wire in here, push it down, and it'll twist that wire.
All right. We're moving right now. We haven't tied these. Is that a bad thing?
No. We can tie this as we go.
Really?
Yeah, but you got to start now.
All right. We got a guy screaming at us over behind.
There's a definite sense of urgency to get these tiles tied together before they drop into the river.
I think you got the hang of it.
Are you pretty good on the gun?
Oh, pretty fast.
Who's the fastest?
As fast as I think, yeah.
Really? You mean that?
Yeah.
Love you, baby. Here we go, Sir Charles. I'm gonna make you proud, Daddy.
All right.
Woo, boy. This thing's so huge. There's stuff flying all around us. People screaming at me. My arms is burning, Charles. All right, we got a little competition going on.
Yes, sir.
He's one ahead of me. Where have you hit him? Bigger, stronger, faster. Let's go. Let's create champions.
Let's go down.
I got the rhythm. We're smoking him. Rookie on the scene. Because I'm a smoking machine. Oh, yeah. I got it now.
One more.
One more gear. Hey, we beat him.
You beat him, man.
I beat him.
All right.
That's because I'm with the best. That's Sir Charles right there, baby. Recognize.
That team launches over 3,500 cement squares a day. That's over 39,000 tons of concrete every week. It's a well-oiled big machine, but as I soon found out, things can also get very dangerous. The deck crew was being evacuated because the concrete mat was getting swept away by the force of the river's current. And Charles was afraid that the mat cables were going to start snapping.
All right, so what do we do now? We gonna cut them off?
We're going to cut him off.
Send me to work, boss.
Several of the anchor wires had to be cut in order to prevent the river's current from overturning the concrete mat.
Right in the middle?
Now, cut the wire right there.
All right, so right here?
Yeah, open it, cut him wide open.
Is he gonna fling back at me? If that thing would have flung up and hit me in the face, that would have been a bad thing.
That wire there just like a wave.
Sharp as a razor.
That wire there cut it just like a wave.
We doing another one?
for you.
I was ready to cut the last cable until I heard something that really freaked me out.
If one
All right,
break,
so babe, if that could break it, could more than one break?
all of them will break all the way down to that boat.
So what is that? Just like chaos? Everyone runs off the
All
boat?
of them, that's right. That's why we get the people out before we let this down.
All right, we'll let the professional cut the last one. Daddy don't feel safe. Bad. All right, so that was pretty scary, man. That big job has some big risks, huh?
Oh yeah, man, that's why we use buddy system out here. I'll pat you on the back, you pat me on the back. That's the way to do it.
I'll take you up on that, man. Thanks for being my buddy. I appreciate it. Have a good day.
You too, man.
Keep sweating.
Yeah, I'm done there.
The work that goes into running that big machine is no joke. That relentless beast combats riverbank erosion by launching up to 20 full 500-ton mattresses every day. The U.S. Army Corps of Engineers concrete mat boat may not be the only fish in the river, but it's definitely the biggest. I woke up this morning, I had a feeling that something big was about to happen. Right here, right now. Today I'm in northern Sweden, in the mining capital of Europe, Gällivare. This particular mine, the Aitik, produces 18 million tons of copper ore each year. Now, from what they tell me, the key to keeping up this crazy pace is the non-stop use of big machines called the rammer hammer and the crusher. The rammer hammer and the crusher. Count me in. Our story starts here with these 2,000 horsepower trucks. Each one carries 220 tons of copper ore excavated from the Aitik mine and dumps the load into this gigantic pit. The rammer hammer pulls the ore down into the hole. What's even cooler, a powerful hydraulic piston at the end of the rammer busts up the big daddy boulders and the little baby rocks. At the bottom of the pit lives the big, bad crusher. That rock doesn't stand a chance in the crusher. Check that out. The crusher chews up the raw ore and spits it out into this underground chamber where a conveyor belt takes it here to the processing plant. And that journey, it begins here, in the pit. No one has been known to get this close to the dump edge. But right here, baby, you got it firsthand. Release the hounds now! Okay, luckily our safety advisor pulled me out of the way and not shoot. Because literally, the second after he pulled me out, a rock fell right in the place I was standing. I guess that's why we have hard hats. Hello, sir.
I'm Al.
Emil. Emil? And what's your job here?
I'm a process engineer.
Process engineer? So do you work on the crusher?
The crusher up to the concentrator.
Sweet. So, I mean, basically, tell me, how does the crusher work?
It's an eccentric cone
Okay.
that goes round and round. And between the walls and the cone, it gets smaller and the stones get crushed.
So how many pounds of pressure does this thing eccentric to break these rocks down?
5,100 pounds.
It's a lot of pressure.
And when the crusher meets a rock so big that it can't break it down, that's when the rammer hammer comes in. The rammer, aka rammer hammer,
Get him!
is for big rocks like these. Break rocks this size, it's much more efficient to use the hydraulic-powered rammer hammer instead of wedges or explosives.
Wow.
Another advantage, the boom arm of the hammer doubles as a rake, pulling piles of loose rock into the pit. Weighing in at over 40,000 pounds with more than a 30-foot reach, the rammer hammer is a multi-million-dollar piece of equipment that really shouldn't be run by a guy like me.
Where's the rammer hammer? I'm coming in!
Unfortunately, the mining company didn't have the good sense to keep me out of their control room. So I want you to know now, if anything happens, well, it's not my fault.
So this is where they control the rammer hammer. How are you doing? My name is Matt.
Thomas.
Thomas? I would really like to drive this rammer hammer. Can you show me?
Yes.
Look at this. Look at this chair. Is this like the ultimate Game Boy chair? It's even got hydraulics on it. There's a load coming right now. I'm going in. Here we go. Wow. It's like a big giant video game. Turbo sectors. I'm going into warp speed. We got trouble, Captain. We got people on the backside. I got bogeys all around us. We got bogeys. All right, I'm in my sights. Radar lock. Blast them. Yeah. Got him. Oh, this bogey. I can't get this bogey off my tail. Loomis, where are you? Why isn't it moving? Are we dead? Did I lose power? Bring it up. All right, so we've got ourselves, or I've got us, in a little predicament here. One side of the crusher is totally lodged with rocks. We got trucks coming in. It's kind of a high stress situation. I'm sorry I backed you up. I've never used a rammer hammer before. Sorry, I'll fix it.
After the rammer and the crusher break the big chunks of copper ore into smaller pieces, they travel on an underground conveyor belt to the processing plant. The ore endures a grueling journey through a series of mammoth mills. These really big, relentless rollers grind the poor little rocks into a fine powder. The powder is mixed with water and chemicals. The mixture is poured into enormous vats where copper and other minerals are skimmed off the top of the soup. It's kind of like cooking.
Sweltering temperatures over 550 degrees. It's at its boiling point. Say I won't. Dare me to stick my hand in there. Watch this. I'm joking. It's cold. It's not even hot. It's like super cold. Thanks.
Okay, so the reason the water is bubbling is because they actually blow air into the bottom of the vat. Now this helps float the copper particles to the surface where they can be skimmed off to create liquid that is 22% pure copper. Next, they suck the water out of this mess with these huge filters. After they filter the soup, they end up with a dry concentrate. They load 10.5 tons of the dry concentrate into each one of these pots. Then, a 2,300 horsepower diesel truck hauls it to the smelter, where it will be turned into pure copper for pipes, wires, rain gutters, and my personal favorite, the humble copper pin. So check it out. We started out with 220 tons of copper ore, but in the end, the whole pile is only going to make 88 pounds of copper. What a process.
You start with a boulder, you ram or ham, you crush it down, then you treat it. And you end up with this fine, precious metal concentrate. Coming up, they're about to tear the paper off right now.
Really big paper rolls
Coming down.
make really big noises.
That's freaking awesome!
And cleaning up the paper mill really sucks.
Oh, that's awesome. It's like a vacuum cleaner. Are there any blades down here that can cut our fingers off? Oh, no. I'm here in the lush countryside of Borlänge, Sweden. When I woke up this morning, it actually occurred to me how much paper and paper products that I use. I bought a newspaper, I paid for it in cash, I got a receipt, I blew my nose with a tissue paper, I cleaned up my coffee stain with a paper towel, I wrote my wife a letter, and I opened up a package. By the way, thanks, babe. The fact is, the average person uses 650 pounds of paper each year. So how is paper made and who produces it? Let's go inside the Studa Enso Quantum Faded Paper Mill and check out the world's largest paper making machine. And my Swedish is still a little shaky, but I'm working on it. Hello, sir. How are you?
Fine, thank you.
Good. I'm Matt.
I'm Anders.
Anders, how do you say hello in Swedish?
Hey, Matt.
That's easy.
Pretty easy, yeah.
So what's your job here?
Yeah, I'm production manager for magazine paper production.
You know, basically take me from the forest
Okay.
to the paper.
I try to. Okay. Okay, we buy spruce. That's the Christmas tree.
All right.
We buy it from local forest here around,
Okay.
and we bring it in by trucks.
How many trees do you use per day, let's say?
Per day, 25,000. The trees around here, they have been used for hundreds of years, so it's growing faster than we chop them down. So it's more trees now than it were 10 years ago. So
You chop down the bottom of the tree and debranch it, or is it?
it's the top of the tree.
Oh, so you just cut the top of the tree off?
Yeah, mostly. Yeah.
The top part of the tree is used to make paper. The thicker bottom part is sent to sawmills to be made into lumber. How many truckloads of logs come in here a day?
About 5 trucks per hour, 24 hours per day.
Oh, so you don't close?
No, never.
Always running?
Yeah,
So we're looking at about 110 truckloads per day.
yeah. And it brings it in for debarking. We don't want that bark. It's dark. If you get it into the paper becomes dark.
Naturally.
So then you have the naked tree without the bark. We ship it down to 3 ships. And those ships will then later on be refined down to fibers. And that fiber will then be paper.
One log, how long does it take for a log to become a piece of paper?
Total process from log to paper is about 12 hours.
12 hours.
Yeah.
And then on a yearly basis, how much paper do you guys produce here?
Maximum capacity is 1 million ton.
1 million tons per year.
Yeah. These paper go to printers. Magazines, newsprint.
So that's what type of paper you guys make here?
Yeah.
Not toilet paper?
No. Not money either.
This place is huge. So from what I hear, you guys are actually labeled the biggest paper producing company in the world. One of 2.
Yeah.
So why so big? I mean, why does everything have to be so huge?
Yeah, the size is really important. You have to be big to make money in this business.
Big machines, big money?
Yeah.
That should be your nickname, Big Money.
Okay.
My first stop, check out the cranes that get the wood off the trucks and into the mill. Eric?
Hello,
Hello, sir. I'm Matt. How are you?
I'm fine, thank you.
You're the crane operator here, right?
Yes,
So tell me, what do you do here?
I take wood from the cars,
Okay.
put it on the table here, and then we take it into the paper machines.
Will you show me how this bad boy runs?
Yes, and here is the main switch. put that on. And this one is forward and backward. And this is for the claw. Shut it or open it. Easy. King the monkey can drive it.
Can I hop in?
Yes.
Tight squeeze.
Yes.
Okay.
Okay.
Am I on? Green switch.
Yes.
There she goes. Basically a lot of hand-eye coordination, right?
Yes. Nice and easy.
I could do this. This is like Atari.
Okay.
Here comes close. Can I close it?
A little bit. Carefully. Nice and easy.
Oh, yeah. That was a nice one.
Yes. That was a nice one.
That good?
Yes.
Pull it up.
Pull it up.
So how am I doing? Are you impressed with my skills?
Yes. Very impressed. You're good at this.
Thank you. Am I making you nervous or excited?
Nervous.
Why?
Carefully.
Carefully.
Yes.
Look at this. Feels pretty cool in here. It's like you're looking down at nothing. There's no floor underneath you. You got a pretty sweet gig here, Eric. Have you ever brought the crane in too low and smacked it up against that thing? And
Yes, that have happened.
are we clean for droppage?
Let's take it down.
Lowering. All right.
Now you can
Now I can open it.
Okay. Then you open.
Oh, look at that. Yeah.
That's great. Up.
Up and away.
Yes.
You're making some paper here, people.
Yes.
Give me some. There you go.
That was a really good one.
Thank you. Hey, step one of the paper making process is done.
Yes.
Thank you very much. I appreciate it.
Thank you for the help.
Thank you. After the logs are dropped on a huge conveyor belt that carries them into the mill, the next stop is the cutting room, where the logs need a 6-foot titanium blade. Hello, my friend.
Hello.
How are you?
I'm well.
I'm Matt.
I'm leave you.
You leave me? Don't leave me.
No, it's just my name.
Oh, okay.
Don't take it in English.
Hey, so this is the control room, huh?
Yes, in the control room, we check on the production and check it. Everything is going as planned.
What are some of the biggest problems that you face in the control room?
When we got a jam,
When there's a log jam, what has to happen?
then one of us have to go over there and fix it.
So, I mean, you have 24 monitors here, 24 TV screens. How do you monitor?
Yes, we get used to it.
But when something breaks down, you're the first guy to see it. You're the one that sends it.
Yeah, right now.
What about when the logs are coming out of there? That looks like a jam, doesn't it?
Yeah, it's
Is that a jam?
It's a jam. It seems so.
Can I go fix it?
You want to go there?
I want to go fix it.
Yeah, you can fix it if you want.
All right, I'll just go right here. I know exactly where that's at. That's right where the logs come out.
Oh, that one. Huh? Good
All
luck.
right, thank you.
Good luck.
Hey, how you doing? I'm Matt.
Matt.
Dan?
Yes.
I heard there's a jam here.
Yes, we have logs from the wrong direction here.
So from here, they're going to go to the debarker.
Yes.
But they can't get there until we cut some of these in half.
That's perfect.
Until I cut some of these in half. All right, let me go. How do I get down there? All right, brother. So we fixed the log jam?
I hope so.
There they go. All right, thanks for letting me help, brother. Have a good day. Next up, the bark stripping tumblers. The wet logs fall against each other in the debarking drum until the timber is stripped clean of all its bark. Bark falls through the floor of the debarking drum. Bark is then stockpiled and later used as a biofuel that provides energy to the plant. I'm standing on a 15-foot mountain of bark. This is basically the only thing they don't use to make paper. Why am I standing up here? I don't know, look like fun. The important thing is how to get down. That's tight. The clean debark logs then make their way to the chipper.
Everyone keeps telling me I have a chip on my shoulder today. We're gonna go repair the chipper. How often does the chipper break down?
Well, once or twice a day.
Once or twice a day? That's not good.
The chipper has an intricate series of sharp teeth that shred logs 24/7. That is, until they get jammed.
So what are you just gonna shove that in there and get it out? Oh, sorry. It's okay. So if you tried to use this right now, would it not work?
Not so good.
Not good. I feel like I'm kind of burning you out. Am I bothering you?
Yes.
I'm getting in your way?
Yeah.
I tend to do that. I don't think my parents held me enough as a child.
I just think you're jammed.
Do you hate me?
No.
We're still friends?
Okay.
That's all I like to hear, Andres. That's what team members do for each other, you know? They pick each other up when they're down. They don't tell each other that they suck. You know, they build people up. They don't tear them down. You know? Andres, you're doing a great job, bud. Thank you. Great job. You're doing great. Thanks for the lesson, my friend.
Okay.
All right.
Andreas and I didn't exactly hit it off. I guess he just wasn't feeling me. The mill's demand for wood chips far outweighs the supply, so the only way to keep pace is to buy additional truckloads of wood chips from the local lumber mills.
Hey, I'm Matt. What's your name?
Hey, Jonas Karls. Hello.
I'm guessing this has to be the chip dumpster, maybe?
Yes, we have some storage of chips.
Why do the chips have to be this particular size?
We want to make a good quality of the pulp, and because of that, we need some uniform size.
Now, this what we're looking down. I mean, I see them all falling down there. Where are they going?
We're taking it into the mill and wash them, make them clean, so we don't have any stones and things like that in the chips.
What would happen if I fell in that hole?
You will get meat.
That's not a good thing.
No, it's not a good thing.
I heard that it's good luck to toss chips in there, like making a wish into a water fountain. Will you toss some chips in there with me?
No, I don't do it.
Oh, come on, Jonas, it'll be fun.
You can. We take some here
Okay.
and make, yes, this is clean and nice chips.
See? Isn't that great?
Yes.
Doesn't it feel good? Come on, just say it with me. You feel alive, don't you?
Yes, it's very nice.
Fantastic. Look at all our dreams are coming
Yes.
true.
That's everything.
God, that felt good. Come here.
Yeah.
Come here. That felt great. So from here, what do we do? Does it make pulp?
Yes, now we're going to make pulp.
Let's go make some pulp. So this thing's pretty big, man. Does it take a lot of power to run this thing?
Yes, we have 8 transformers which generates about 350 megawatts.
Big power, big paper, big machine. Let's check it out.
Okay, Matt, here we have the grinder. You have the chips, which we saw outside. It comes in here, and it goes out here, and here we have the pulp. And this rotates 60, 70 miles per hour.
Yeah.
And then you have a second one up on this one, and they rotate very fast with only a half millimeter space.
Like this?
Yes, like this.
Oh.
And then we put in water. Chips, flour, and water.
So wood and water makes paper.
Wood and water makes paper with a lot of energy.
What machine does this go into?
Refiner.
Can we go check that out?
Okay, do it.
All right, so tell me about the refinery.
It's a very big machine. We have two engines of 50 megawatt power each. We need a lot of energy to separate the fiber.
Look at this.
Here we have some pulp from the refiner.
What was your name?
Anders.
Anders. How are you doing? Nice to meet you.
Oh, it's hot. It's very hot. You need gloves because of the process is under pressure.
Wish I would have known that fact before I did that. So how hot does this pulp get?
It's about 150 degrees.
That's pretty hot. Might want to use gloves next time. So how do you make pulp into paper?
We wet it up once again, and we have to take away the clusters of fibers, for example. No fiber together, only 3 fibers. So they're very small. Yes, it's more healthy than smoking.
You ever chew tobacco?
Well, this is with me.
You'll like it. Making paper requires big machines. And at 600 feet long, this is the biggest machine at the mill. Okay, so now we've seen the logs and how we get from a log to a wood chip to a pulp. Now I want to know how we get from pulp to paper. I'm in another control room, and I'm looking for the superintendent, Annika, to show me how. Annika, I'm Matt. How are you?
Hi, welcome.
Hi. How do we get paper from pulp?
You have like a huge box when pulp comes into the machine. It's called the head box, where it's diluted to 98% water, and you spray out the diluted fibers, and it goes between two layers of fabrics, where with vacuum on each side you pull away and you suck out the water in the forming sector, and then you move into the next part of the machine, the press section, and there you press out the water.
I had no idea there was that much water in paper. And what comes after the press section?
You have to go through the drying section. 50 gigantic rolls steamed up inside and then incredibly hot. And then the paper goes like in slalom.
So it's keep getting hotter as it goes and goes and goes?
Yeah.
So
But you reach a final point where you can't take any more water out, and then it's where it comes out.
How long does it take for it to dry?
10 to 15 seconds.
In only 10 seconds, so it's going pretty fast.
It's about 100 kilometers per hour.
60, 70 miles an hour. And then it comes out, it's paper, we're ready to go?
Yeah, it's paper. The only thing you have to do is that you control that all the parameters are correct.
It's unbelievable. How do you measure something that's going 70 miles an hour?
It's quite advanced. You have lasers and things like that.
This place is huge. This machine is huge.
Yeah.
Why does it have to be so big?
The demands for efficiency are so high. It's just economics.
So bigger is better.
Bigger is better, definitely.
Bigger machines, bigger problems.
Yeah. If you get a tear, the paper breaks in the machine. And then we have, of course, mechanical breakdowns.
Right. I met one of your mechanics in the wood house.
Yeah.
He didn't like me.
Most mechanics are quite nice.
I really enjoyed this conversation. I want to go get up close and personal with one of these machines. Is that
Sure.
okay?
Yeah, good.
Try not to fall in.
Good.
Thanks, Annika.
Bye.
Bye.
They're about to tear the paper off right now. I don't know how they do it, but I'm kind of interested to see. Let's check it out. That roll's coming down. That's freaking awesome. Non-stop. Sound like me, baby. Non-stop. 110% power all the time, every time. All right, so we just saw the paper snap. Now it needs to be cleaned up. My man Shell here is going to show me what to do. Shell, I'm Matt. How you doing?
Hello.
How much paper is that?
115,000 meters.
450,000 feet. I'm Matt Rogers, and this is a very big roll of paper.
Each roll of paper needs a clean cut prior to packaging, and the excess paper gets recycled.
Shoving the paper down here. Moving, cleaving, plowing, clothing. Is it sucking it down?
Yes.
Oh, that's awesome. It's like a vacuum cleaner. It's like a giant paper shredder. Are there any blades down here that can cut our fingers off?
Oh, no.
Have you ever lost a man yet?
Only two.
Only two. Get out of here! What the heck is going on in Sweden? I don't like it here anymore. This is the Fruchtorage. So what is this? Is this like a giant paper cutter?
Yes.
The strip of paper this machine cuts from a finished roll will be sent to the lab to make sure color, thickness, and gloss level are just right.
Fruchtorage. Oh. Is that bad?
Yes. Can we try again?
Here we go, round two. Steady.
Perfect.
Halfway there, Shell.
Yes, take it faster.
A little faster, Flügen. Eins geht Flügen. Did we do it?
Yes.
Flügen, Flügen. Hey. Nice.
So, perfect.
Flügen hiking only 2 times. Super Flügen.
the standards, whether it be, the wrong color, holes in the paper, material. So when this happens, they get the guillotine. It's not pretty.
Nothing goes to waste, though. The paper gets recycled back to pulp for a second chance. Finally, it's time to clean up with the air hose.
Taking this baby up to 50.
Is then cut to various sizes depending on the customer's order. Rolls are then pressed and finished to the desired gloss and texture.
So after a roll has been cut and approved, it's put on this conveyor belt and sent into the warehouse for wrapping, otherwise known as the Genomgang Verbjuden. I think those guys tried to jump me in high school.
At the end of the line, robotic arms and conveyor belts move the giant rolls of paper to the shipping warehouse.
I gotta confess, in this high-tech day and age, I pretty much take paper for granted. But the big dog here in Sweden has changed my way of thinking. And this warehouse behind me is over 10,000 tons of paper. Some of it could end up in a newspaper stand near you. Truth be told, the world's largest paper-making machine continues to grow. Big. Scheiden, five, and going to out today. Everybody join me, Sweden, going to make some paper today. All right, we're judging two things here. Flight time, which is distance, and style, creativity, all right? So make it pretty. You're going down, sister.
Free!
Let's go. Okay. I'm Matt Rogers.